Prime factorization. Prime factorization occurs when we divide the numbers into all prime numbers. One method for finding these numbers is to use a factor tree. So let's go ahead and look at example 1 and use the factor tree. So a vehicle is able to travel 480 miles on 1 tank of gas. What is the prime factorization of 480? So to do this problem, we would have our starting number at the top, and then we know that 0 is even, so then we would go ahead and just divide it by 2 for the first one. So we have 2 here, so we have 480 divided by 2, which is equal to 240. Now, 2 is a prime number, so we'll just circle it because we're done, as we just need to divide them into prime numbers. Now, 240 can be further divided. This is also even, so we can divide by 2. So we have 2 here, so 2 can go into 240 120 times. So we will keep that 2 there, and we're going to further divide out the 120. Now, 120 can be divided by 2 again. So let's go ahead and go 2, and 120 divided by 2 is 60. Circle the 2. Now 60 divided by 2 is 30, and then we can divide 30 out. So 30 can be divided by 2 again. 30 divided by 2 is 15. We circle the 2. Now we're here at 15. 15 is not even, so we would have to use a different number to divide out. And 15 can be divided by 3. And so 15 divided by 3 is 5. And 3 is a prime number, and 5 is a prime number. So we would circle them to indicate that we are done dividing that number out as far as we can. So now we have our factor tree, and it's completely all divided into prime numbers now. So we have 1, 2, 3, 4, 5 2's. So we'd write it like this. We have 2 times 2 times 2 times 2 times 2. And then we have times 3 times 5. All these numbers, when they're multiplied, is equal to 480. So let's reduce this to make it look a little bit nicer. So we have 5 2's. So we would just write 2 as our base number, and we would write 5 as our exponent to indicate that there's 5 2's. Then we'd have times 3 times 5. And this would be our final solution for this problem. Now let's go over another example. And we're going to use a second method, and we're going to be using the divisibility ladder. A long road trip was 1,890 miles round trip. What is the prime factorization of 1,890? So for this problem, we will have our number, and we're going to draw what will begin our ladder like this. Now, 0 is even, so we're going to first divide by 2. Now, 2 can go into 1,890 how many times? So what we kind of do is we can go, 2 can go into 18 9 times. Now, 2 can go into 9 4 times, but we have a carryover because 2 times 4 is 8. So 9 minus 8 is 1, so we carry that 1 over there to 10. Now, 2 can go into 10 5 times. So we just did long division in a much simpler way in this brackets. And that's how you do our divisibility ladder. So let's keep going. So now 945 can be divided by 5 because we're ending in a 5. So let's do 5 out here. Now 5 can go into 9 1 time. We carry that 4. 5 can go into 44 8 times, carry the 4. Now 5 can go into 45 times, 9 times. So now we have 189. So what can go into 189? It's not 2 and it's not 5. So let's check. So 1 plus 8 plus 9 is equal to 18. And if we divide by 3, that equals 6. So we can divide by 3. It's one of our divisibility tricks. So let's put a 3 out here. 3 can go into 18 6 times. Now 3 can go into 9 3 times. So now we have 63. So let's now divide again. And we can divide this by 3. So we have 3 out here. So 3 can go into 6 2 times. 3 can go into 3 1 time. So now we have 21, which this can be divided by 3 again, and then we get 7. Now, the 7 is a prime number, so we're not going to keep going. And so now we have all our prime numbers that are on the outside. And so if we just multiply all of them out, so we have 1, 2, now let's do the 3s. So we have 3 3s, 1 5, and 1 7. Then let's make this a little bit more simpler into 2 times 3 to the raised to the 3rd power times 5 times 7. And this would be our solution to this problem using the divisibility ladder.